Okay, I'm going to go over, let me get up here. I'm going to go over the Venn diagrams on the sample final I gave you. So I'll use the whiteboard here. Excuse me. Okay, so number 2. Let's do number 2 first. Let me write what I have down first, and it should be all S. Okay, that's what I have. The letters really don't matter. You could have different letters, but S stands for people who hold stock in the company. V stands for people who can vote. H stands for people who are identical to Mr. Hansen. Okay? Because again, in categorical syllogisms, if you're going to talk about individual person like Socrates, you have to say all people who are identical to Socrates. So all people who are identical to Mr. Hansen. Okay? So that's what we have. And here's the Venn diagram. So S, V, H. All S or V. To do all S or V, you darken every section inside S, which is outside V. Every section inside the S circle, which is outside V. So you darken those two sections. In Venn diagrams, when you diagram all and no statements, you always darken out two sections. The next one is no H or V. So we darken, there's nothing inside the H circle and the V circle. So there can be nothing here or here. We darken those two circles out, sections. Now, we don't diagram you don't diagram the conclusion. You look at the picture and you ask yourself, do you know that no H or S is true? Because in a valid argument, if the premises are true, the conclusion has to be true. This picture here of the Venn diagram tells you it says exactly what these two say. All the information here is contained here. So if this is a valid argument, we should be able to look at this picture and know that no H or S. Do we know that? Yes. Look in the intersection of the H and S circles, and there's nothing there. They're both darkened out. So it's a valid argument. Okay. I've got to get an eraser here, so I'll be back in a second. Okay, so these are erase this. Okay, number 3. All B or J. All B or J, all B or P. Therefore, all P are J. So B stands for things that Bob, what did Bob do? He bought them at the junk things. I don't have the thing with me, but things that Bob purchased, I guess. Things that Bob purchased at the carnival all the things that Bob purchased at the carnival are junk. All the things that Bob purchased are things that at the carnival are things that Pete purchased at the at the carnival. And note, it's very important that's all B or P, not all P or B. So think about that. It's all the things that Bob purchased or things that Pete purchased. It's not all the things that Pete purchased or things that Bob purchased. And then do we know that all the things that Pete purchased are junk? All P or J. So let's do the Venn diagram. We could figure this out even if you know the rules. So let's look at, well, let me do the Venn diagrams first. B, J, P. All B or J. Darken everything inside B, which is outside J. That's these two sections. All B or P, darken everything inside B, which is outside of P. This has already been darkened here, so we just darken that. Do we know that all P, all P or J, and we don't, because all P or J, this section would have to be darkened out. Everything inside P, excuse me, this section is not darkened out, therefore this argument is invalid. So this is an invalid argument. We can say one fallacy it's made. One of the rules is that anything distributed in the conclusion has to be distributed above. This is distributed. That's not distributed. So it violates that rule. That's the only rule it violates, but that's enough. Okay, now I want to look at number 5. Number 5 is we have to supply a missing premise. Supply a missing premise. Okay, to make it valid. So no MRP. And then we have to put something in here. And we're supposed to be able to get to some S or not P. So MPS, no MRP is here. And we want to get to, so we know that some S or not P. We want to know that something is here or here. So how are we going to do that? We have to use an S and an M here, because in a syllogism each term appears twice. So we've got the P here. We need another M. Anyway, it's going to be some S or M. Some S or M. There's something here. Some S or, that's a missing premise. Do we know that some S or not P? Yes, some S or not P. That makes it a valid argument. Okay, that was number 5. Number 6 is talking about the rules. Number 6, okay. Number 6, all P or M. This is not a Venn diagram, but just want to know what rules are violated. Some S or not M. And therefore some S or not P. Okay, one of the rules is that, rule 3 I think says that the number of negative premises has to equal the number of negative conclusions. And that's okay, it passes that test. Because we have a not and a not. So one negative, that's fine. The middle term has to be distributed. The middle term has to be distributed one time. It passes that test because this term, that's distributed. That's a no statement. Predicate term of a no statement is distributed. And then any term distributed down here has to be distributed up here. That's distributed. The P, that's distributed. So number 6 is a valid argument. It doesn't break any rules. Okay, let's do number 17. number 17 is going to be all M. All M are E. Some S are M. Therefore, some E are S. S stands for Martians, E for explorers, and M stands for Martians, E for explorers, and S for suspicious people. All Martians are explorers. Some suspicious people are Martians. Therefore, some explorers are suspicious people. Do the Venn diagram. It doesn't matter where you do the circles. So you could put I could have made that M. I could have made, it doesn't matter. All M are E. Darken everything inside M, which is outside of B. That's the rule for all. Some S or M, there's something inside S and M, that's here. And do we know that some E or S? Yeah, there's something inside E. That X is in the E circle and the S circle. Okay, so that's number 17. We've got 2 more to go now. Okay, number 18 is some S or R. Some S or R. S stands for sour things. R stands for red things. A stands for apples. Some apples are not red, not R. Therefore, do we know that some apples, some A, are not S, are not sour? Okay. Venn diagram, S, R, A. Some, these are both some, so it doesn't matter which one we do first. Some S or R is going to be, there's something inside S, and it could be here or here. That's the rope. That's called the rope. It just means it could be here or here. You could put an X there if you want. There's something here or here. The rope just simply means or. Some A or not R, something inside A, which is not, it could be here or here. Anytime you have a rope, even one rope, let alone 2, it's always going to be invalid. So this is an invalid argument. Do we know that some A are not R? Some A are not S. No, because look at this one could be here. That's in the S. And this could be here. So we don't know that this is true. We don't know that some A are not S. Okay? So anytime this is called the rope. It just it could be the X could be here or here. Your book puts the X on the line. Okay? I'm not doing that because sometimes it's hard to tell whether students are just going fast and being sloppy. So I do the rope. Okay, let me do the last one. The last one, which is all T or M. All T R M. This is number 19. All typologists are mathematicians. Some typologists, some T, are statisticians. Do we know that some mathematicians are not statisticians? Some M are not S. So we have T, M, S. All T or M is here. Darken everything inside T. Some T or S here. Some T or S. Do we know some M are not S? No, we don't. Some T are not S. Oh, some T are not S. Some T are not S. Do we know that some M are not S? Yes, we do. It's a valid argument. Okay, that's all. I got to end this thing so I don't run out of, so I can publish it.